You have an LS Electric iX7 servo system and are ready to begin basic software configuration. For other control options, check out our L7C and L7P setup video here. Nearly all of it applies to the Fox and iX7 systems and is a great additional resource. We are starting with a pre-configured test bench setup. For more details, please review our iX7 servo system build video, available here. We have DriveCM open and are connected to the iX7 servo via USB. We have drive status information, including the status and alarm information, over here. Let's start out by setting the drive to default parameters so you and I can start in exactly the same place. We will go to Setup, Restore Default Parameters, Restore All Parameters, and then confirm that we want to reset all parameters to factory setting. Once the ensuing pop-up window disappears, we will press the Save to Memory button to save the default parameters to the drive, and then cycle power. Once power comes back up, we reconnect the software and are ready to get started. Our first step will be informing the system that we are operating on 120 volt AC power rather than the default 230 volt setting. We fix this by setting bit 15 of parameter 0x2034 to a value of 1. This corresponds to a decimal value of 32768. We then navigate to the Object Dictionary in DriveCM, select the Basic tab, scroll down to parameter 0x2034, enter 32768 in the value field, and press Enter to send the change to the drive. We must then press the Save to Memory button to ensure the change persists through a power cycle. This change will require us to cycle power to the drive, but since additional parameter changes remain, we'll perform the power cycle at the end. We are now ready to proceed with the Setup Wizard. After clicking Setup Wizard on the left side of the screen, we select Online and confirm that we want to read the drive parameters. The wizard automatically selects the iX7 NH drive, and we click Next. For the motor settings, it is most efficient to allow the system to configure these automatically, so we select Auto Setting and click Next again. We keep the counterclockwise direction set as positive and click Next a third time. Then we configure the electronic gear ratio, which is an important step because it allows us to convert difficult-to-use encoder resolution values into practical user units. The encoder on this motor is 19-bit, or 524,288 pulses per motor revolution. We enter this value as the numerator and press Enter. We can now calculate a useful denominator. Our linear actuator has a 1/4 inch pitch, meaning it moves 1/4 inch per motor revolution. By setting the denominator to 250 user units and pressing Enter, we define one motor revolution as 250 user units. This results in 1,000 user units equaling 1 inch of linear travel, making each user unit equal to 1 mil, which is far easier to work with for this application. To be clear, this does not affect the motor's accuracy or feedback. It simply allows us to command motion in 1 mil increments. If finer command resolution is required, we can adjust this ratio accordingly. We are not using the encoder output from the drive, so we leave that section unchanged and click Next. The next few screens are left at their default values, as no changes are required for our application. Refer to the manual for detailed explanations of each of these settings. Next, we configure the digital inputs. The Overtravel switches and home sensor are wired directly to the drive. We are using DI1 for the positive overtravel, so it is set to POT with low true logic, as the sensor is normally closed. DI2 is configured as NOT with low true logic, and DI3 is set to home with high true logic for the normally open home sensor. All remaining inputs are set to Not Assigned. We are not using any of the drive's digital outputs, as all status information will be communicated over the EtherCAT connection to the XMC motion controller. Therefore, each output is set to Not Assigned. If we had a braked motor, we would need an output assigned to brake control. We leave analog monitor mode unchanged and proceed to the homing method configuration screen. There are many homing method options available, so please refer to the manual for detailed explanations and diagrams. The software provides preview graphs, which correspond to the illustrations in the manual, and help describe how each method functions. For our application, we want the system to search for home in the positive direction, and after the home sensor transitions low, reverse to the next Z-pulse. This corresponds to homing method 9. We set the switch search velocity to 3 inches per second and press Enter. The marker search velocity, which begins after the home switch goes low, is set to 1/4 inch per second, with both acceleration and quick-stop deceleration set to 1 inch per second squared. The home offset remains set to 0. We click Next, write the configuration to the drive, and then click Save to Memory. This will save the settings to the drive's non-volatile memory, so they are retained after a power cycle. Once that process is complete, we cycle power to the test bench. After restoring power and reconnecting to the drive, we return to the object dictionary to verify that the change to parameter 0x2034 is present, and it is. We can now rerun the Setup Wizard, go online and verify that all settings have been retained. Electronic gear ratio, check. Digital inputs, check. Digital outputs, check. Homing method, check. All changes have been successfully saved. Now we perform a simple jogging test. The actuator starts near the middle of travel, so the home sensor should already be active. Viewing the digital input screen, we confirm that the home sensor input is on, indicating proper operation. We then navigate to the jog screen, set the speed to 500 RPM, and enable the servo. Jogging in the forward direction, we reach the positive overtravel, and the software correctly reports a POT alarm. Forward motion is blocked, but we can still jog in reverse. As expected, the POT alarm clears, and when we reach the opposite end of travel, the NOT input activates. This confirms correct operation. For additional information, please refer to the Quick Start Guide available at AutomationDirect.com. It condenses key information from the LS manual into an easy-to-use format, while the full manual remains the best resource for in-depth technical reference. We have now successfully configured our iX7 servo drive using the DriveCM Setup Wizard. The process was straightforward and quick, and the system is now ready for EtherCAT control from our XMC motion controller. Just another reason Automation Direct is the #1 value in automation. If you have further questions, please contact our free award-winning technical support team. If you want to see EtherCAT motion products, click here. If you want to see more videos on EtherCAT motion control, click here. If you want to subscribe to our YouTube channel, click here.